Okay, so we wanted to figure out what was going on in trial 2 of the pivot activity. Um, Trial 2, remember, was try to find Connor's mass. We're going to have Connor and Christine pushing off each other. How can we use this information to find Connor's mass? Where is it? There it is. Um, so I really only need to stay on the video here. I'm going to jump over to this whiteboard. Find Connor's mass. On the left side, we have Christine, who weighs 60 kilograms. Haley weighs 69 kilograms. And the cart they're sitting on at 22 kilograms for a total mass of 151 kilograms. On the right side, we've got Connor, whose mass we don't know, and the cart, also 22 kilograms, which is going to be some total, which we still don't know. So how can we use Newton's laws, momentum and such, to find his mass? Because mass is in those laws, remember. So at the start, nobody's in motion, and there are no forces in play yet. I am reading. The total momentum is 0. Nobody's in motion. Because momentum is conserved, the total momentum can't change. Thus, the total momentum at the end of the video, when they're moving apart from each other, must also be 0. The way this can be true is for the momentum of Haley and Christine to be equal and opposite to the momentum of Connor. If we can find the momentum of Haley and Christine, or something related to it, we know the momentum of Connor. Since momentum is mass times velocity, and we can measure Connor's velocity, we should be able to find his mass. So I'm going to look at Newton's second law for a moment here and rearrange it, actually. Change it up a little bit and make it more useful to us, perhaps. So remember, Newton's second law says force equals mass times acceleration. Well, this is the same as saying force equals mass times, what is acceleration? It's the change in velocity over time, you know? So if we consider that definition, we can rearrange the equation like this. We just replace acceleration with change in velocity over time. And now we can do a second step and say that force, we're going to multiply both sides by time. Force times time equals mass times change in velocity. Now, Newton's third law, I'm reading again, says that the force exerted by Christine on Connor is equal to the force exerted by Connor on Christine. We can see from the video, clearly it makes sense, that the time of the force that they exert on each other is equal. The time Christine exerts on Connor is equal to the time Connor exerts on Christine, and the force is equal. Thus, we can set Connor's mass times his change in velocity equal to Christine and Haley's mass times their change in velocity. We can measure their velocities after their hands are no longer touching and put the values into the equation. So here we have Christine and Haley in purple on the left and Connor on the right in green. We have their side of the equation, their mass times their change in velocity equals Connor's mass times his change in velocity. And I've already written down that Christine and Haley's total mass is 151 kilograms. We added that up from the information we were given in the pivot. Now we just need to find their change in velocity. Remember, their velocity at the beginning was 0, so all we really need is their velocity at the end. So to find their change in velocity, we need to find the moment in the video where their hands are no longer touching. And I've got this all set up for myself to make it quick. I want to find frame and time 0. Oops, there we go. You would have to do this on your own. Find that moment their fingers are no longer touching. Set the rulers somewhere on the cart or somewhere that you can measure how far they move. Because remember, velocity is distance divided by time, reset the stopwatch to 0, and then we just go forward in time. I'm going to zip through this a little ways. And we only need to do this once for both of them. I want to make sure Connor's cart doesn't quite go off the screen. I'm going to see if I can get him to 30 centimeters, right? There we go. And we can see that Christine and Haley have moved about 18 centimeters in the same amount of time. Exactly what we'd expect. They're more massive. They should have a lower velocity than Connor by himself. So this took 0.2333 seconds. So Christine and Haley, 18 centimeters in 0.233 seconds. And Connor, 30 centimeters in 0.2333 seconds. I'm going to come back here, slide this up a little bit. I'm going to give us the purple for Christine and Haley. Now, that was 18 centimeters in 0.2333 seconds. Now, I really want this in meters, so it's really 0.18 meters. Now, velocity is distance over time. We put in their distance, 0.18 meters over their time of 0.2333 seconds. I'm going to pause this and get a calculator. My calculator says their velocity is 0.77 meters per second. Get rid of that thing there. I got to do the same thing to Connor. I'm going to kind of keep their velocity hovering over there. Go to green. Connor went, what was it now? He went a distance of 30 centimeters or 0.30 meters. So his velocity must be distance 0.30 meters over the same amount of time, 0.2333 seconds. And again, pause for a calculator. So calculator says his velocity equals, shoot, what was it again? 1.29 meters per second. So we have velocity for Connor and velocity for Christine and Haley. Let's see. I'm going to keep my green here. We don't know his mass. We'll call his mass. Well, I'll just leave mass. Mass times. Now remember, he went from a velocity of 0 to a velocity of 1.29 meters per second. If he'd had a starting velocity, we'd have to do some subtraction, but he didn't. We don't really, 1.29 minus 0 is 1.29. We don't really need to work on that. So mass times the change in velocity is 1.29 meters per second. And let's be slick here. Black equals, go back to purple for Christine and Haley. Their change in velocity, same thing. 0.77 minus 0 is 0.77 meters per second. 151 times 0.77 is, come back to my calculator, 116.27, 116.27 kilogram meters per second equals 1.29 times mass of Connor. So we got to divide both sides by 1.29. This is going to cancel out and leave us with mass over here. And what is 116 divided by 1.29? Jump to the... This is 90.1. That says Connor's mass is 90.1. Now remember, this is not technically Connor's mass. This is Connor and the cart's mass. So if we come back up here, we got 90.1. We got to subtract the 22 kilograms. 90 minus 22, 80, 70, 68.1 kilograms. 68.1 kilograms is Connor's mass. There we go. Hope you enjoyed this.